All right. So, day 7. Happy Easter, which I think is tomorrow. All right. A go-kart has a maximum weight limit of 240 pounds. Maximum. So, the maximum can weigh 240. So, the go-kart, let's use, well, they're using W. The go-kart can be 240 pounds or less, and therefore the less or equal to sign. Okay. And again, remember that it says it has a maximum weight of 240, so automatically it can't be this one. I'm sorry, that's not what I meant. This one, it can't be over 240, so that's gone. It can't be equal or greater to 240, so that's gone. So you're between A and B. Okay, can it be 240? Yeah, you can. So that's our answer. Okay. 2. The scooter can travel a maximum speed of 45 miles per hour, which inequality model shows all the speeds S. So the scooter, the maximum speed is 45. Can it be over 45? No, it can't be over 45. So therefore, this guy is gone and this guy is gone. Can it be 45? Yes. Can it be equal to 45? Also yes. So that's our answer. 3. Ruth brought 4 candy bars and 3 deck of cards. The candy bar cost him $35 each. He spent no more than $12, which inequality best represents the cost for 1 deck of cards. Candy bars were, well, we know the price of candy bars, 1.35 times 4. So the candy bars, all right, the candy bars is 1.35 times 4, so that gives us $5.40. So if you subtract that from 12, we're left with $6.60. Right? And then we bought how many? 3 deck of cards. So we have $6.60 left. We divide that by 3. We left that each deck of cards is $2.20. So which inequality represents the cost for 1 deck of cards? Anything with 220. Well, it's not greater than 220. That's not possible. It's not 355 because I don't even know where that number is coming from. So neither is this. So each deck of cards can be equal to 220 or even less. Or look at the inequality below, which once shows the solution. Well, let's solve it. 2x less or equal to 6, we'll solve it the same way we solve it in equations with inverse operations. So that says negative 2 times x. The inverse operation is division, so we're going to divide this by negative 2 and divide this by negative 2. That simplifies to 1, right? And 6 divided by negative 2 is negative 3. So remember, when we're dividing by a negative number here, we have to change the inequality sign to the other way to keep the proper inequality the same. Okay? So x is greater than negative 3. We have a 5. Find the values of x that will make, all right, that will make the solution true. Well, x plus 3.5 greater or equal to 9. Again, we're going to subtract 3.5 from each side. That goes away. X is greater or equal to, what is that, 5.5? 5.5. So as long as it's greater than 5.5, then it will be a solution to inequality. Well, 15 is okay. 10.2 is okay. 15 divided by 2 is 7, so that's okay too. 6 is okay. 5.5 is okay, but 5 is not okay. So any number greater than 5.5 will make that inequality true. So we have everything but 5. 6, cost of renting a boat is $20 plus $2.50 per hour. where X is the number of hours Mike wants to spend less than 50, right? So let's start setting up an inequality. So less than 50 means there's your less than 50, right? So let's start with that. And then let's represent the first sentence as an expression. We're going to pay $20 no matter what, plus $2.50 per hour or times X. So that's an inequality. Now, less than 50, is there anything that looks like less than 50? Well, yeah. This guy here and this guy here, right? So these two are out because he doesn't have more than 50 to spend. So you don't even have to look at those. So which of these two look like the one I have? So 20 plus 250x, less than 50. And the other one says 20x. It's not 20 per hour. It's 250 per hour. So correct answer is D, right? Because that has the relationship we're looking for. All right, so this one looks okay so far. Pretty straightforward. 7. Chris won at most 300 tickets. So if he won at most 300, did he win more, greater than 300? No. So it was 300. That means that whatever he won was less than 300 or even equal to 300. So right off the bat, this one that says greater than 300 is gone, and this one that says greater or equal to 300 is gone, and this one that says also greater or equal to 300 is gone. So this, I'm not even paying attention to it. He spent $128 and 128 tickets on a ball and the rest on gum. Each gum was 25 tickets, which inequality can be used to determine the greatest number of pieces of gum Chris would have purchased. So, we know for sure he spent 128 tickets plus 25 tickets per gum. Right? And then, yeah, here we go. That's the correct answer, right? 128 is exactly what I have here. 128 tickets, and then each gum was 25 tickets. All that has to be less or equal to 300. 9. Tim took a quiz, blah, 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 blah. What is the maximum number of questions tipped correctly and still pass the quiz? So let's solve the inequality. So 25 minus x minus 1/4 x. All that has to be greater than 17. So now, if this was a test and you forgot, I don't know, for some reason you forgot to solve it, all you gotta do is plug this number here. Instead of x, plug it in here, and see if it's greater or equal to 17. And then if that doesn't work, plug the 7. If that doesn't work, plug the 10. If that doesn't work, plug 19. That's your last resort. Alright, so you're looking for a number that I can plug in here and here so that my expression, my inequality, the left side is greater or equal than 17. But you still remember how to solve it. Remember, there's a 1 here, security property, that comes out the same. 1 times 25 is 25, 1 times negative x, minus 1/4 x. So now the only thing with 1/4 x, I don't want to deal with fractions, I'm going to leave it as a decimal. 0.25x greater than 17. Can I combine like terms? Yeah, this guy right here and this guy. Now remember, there is a 1, an invisible 1 here, so that's actually negative 1 and negative 0.25. So we're going to get combine like terms, negative 1.25x greater or equal to 17. Now we just get to solve it. So line in the middle, minus 25, minus 25, and we're left over with negative 1.25x greater or equal to negative 8. We gotta divide both sides, line in the middle again, divide both sides by negative 1.25, divide by negative 1.25. That simplifies to 1. X is less or equal, remember, divided by a negative number, flip the sign the other way, and we got negative 8 divided by 1.25, and we get 6.4. So any number that's less than 6.4 will make that inequality true, and it's just this one. So the maximum number of questions that he can answer correctly and still pass his test is 6. Right? Anything above that, he fails. 10. Did I do 10? There's 150 bucks in the account. We deposit 200 in the account every month. Okay. He needs at least $700 to buy a used car. Here's the inequality. How many deposits must he make? Well, and again, we can solve this right off the bat. Right. 200x plus 150 greater or equal to 700. Line in the middle. Let's get rid of the 150. That's 550. That goes away, and we have 200x. Divide both sides by 200. X is greater or equal than, what's 550 divided by 200? Oops, 550 divided by 200. 2.75. There you go. X is greater or equal to 2.75. 11. Which inequality below, which graph below shows the solution to the inequality? Well, let's solve it. Distributed property, right? Here, distributed property. 2 times 2x is 4x. 2 times negative 6 is negative 12. Greater or equal to x plus 3. The variables on both sides, let's get rid of the ones with smaller coefficient. You can get rid of it whichever one. That's just a suggestion. So I'm going to do minus x here. I'm going to do minus x here. X and x goes away. 4x minus x is 3x. Minus 12. And then bring the 3 down. We're going to add 12 to both sides. Right, and then the 12 goes away, and I'm left with 3x greater or equal to 15. Divide both sides by 3. X has to be greater or equal to 5 to make that inequality true. So, greater or equal to 5, here we go. Dotted. So, if you were to draw a number line, right? So, 5, 6, 7, 4. Circle on top of 5. Is it shaded? Yes. And we want numbers that are greater than 5, and they're this way. And the only one that looks like that, or is like that, is D. 12. Use the inequality below to answer your questions. Which graph? Okay, again, same question. So we have 5 minus x, x are equal to 8. Line in the middle, let's get rid of the 5, so we do minus 5, and negative x less or equal to negative 3. Now remember, there's a 1 here, right? So that's not our answer. We want positive x. So I'm going to divide this by negative 1, and we're going to divide the other side by negative 1. Divide negative by a negative number? Well, negative 1 and negative 1 is positive 1, and 1 times x is just x, which is what we wanted. But because I divided by a negative number, the inequality switches to the other side, right? It becomes greater or equal. And negative 3 divided by 1 is positive 3. So if I were to graph this, circle on top of 3 is 3 part of solution, yes. And every number greater than 3 is also part of solution and points that way. We have anything that looks like that? Yes, we do. Letter A. Okay, 12, 13. And I guess this is an inequality review. Which of this shows the solution to the inequality? Well, 12 minus 4x less or equal to 20. Line in the middle. Minus 12, minus 12. This goes away. Negative 4x less or equal to 8. Divide by negative 4. Divide by negative 4. X is greater or equal to negative 2. Right? Because 8 divided by negative 4 is negative 2. So, inequality, negative 2, negative 1, negative 3. Circle on top of negative 2, shade it, because negative 2 is part of the solution. And we want numbers that are greater than negative 2, which also happens to be to the right. So, and that looks like this guy right here. So the answer is B. 14. Oh my god, a lot of inequalities. No kidding. Alright. Careful here. Right? Don't just remove the parentheses because of that subtraction sign here, the minus sign, everything inside the parentheses is going to switch, right? So remember, there's a 1 here. Distributed property. Negative 1 times x is negative x, and negative 4, negative 1 times positive 4 is negative 4. See how they come out the opposite? Parentheses are gone. Greater or equal to negative 7. Now, just solving. Plus 4 here, plus 4 here. That goes away. Negative 7 plus 4 is negative 3. And then this comes down as negative x. We're still not done. Again, there's a 1 here. Divide this by negative 1 and divide this by negative 1. So that simplifies to 1, or just x. Switch the sign, because we divided by a negative number. Negative 3 divided by negative 1 is positive 3. So which one is the solution? So think about how we graph this. 3 is part of the solution, so we shade, and we want numbers that are less. Goes that way. Which is, sorry, it's so tiny. A. And one more. This one is simple. Calvin correctly concluded the solution was n greater than 20. Which statement could be used to justify the solutions? The Calvin's solution is incorrect. When Calvin divided by negative 2, the sign of the answer should have been negative. When Calvin divided by negative 2, the answer she should have changed an equality sign to less or equal. All right, when simplifying, all right, let's actually do it. Greater equal to negative 26. So the first thing we do is get rid of the 14, right? So minus 14 here, minus 14. That's gone. Negative 2n comes down. Greater or equal to negative 40. From here, we're going to divide by negative 2, divide by negative 2. That simplifies, n is left over. We switch the sign, right? And that becomes positive 20. So what is it that, so this is the actual answer, and this is what she got. So what is it that she forgot to do? Well, it looks like the one I just read. When Callie divided by negative 2, which is what we did over here, right, on both sides, she should have changed an equality sign to less than equal. Yes. Did she? No, she kept it as greater than or equal to. So, final answer, B. All right. Wow, that was really simple.